So if you recall, last time we talked about factory methods, and I talked about all the different ways to make streams using different techniques. And we'd also had talked about other types of things before that, like splitterators, which is yet another way to make a stream. And what we're going to do today is we're going to talk about one of the fundamental differences of a stream versus more traditional ways of iterating through collections. And that'll expose us to the topic of internal versus external iteration. And earlier versions of Java only supported external iteration. Java 8 and beyond support both external and internal iteration. So we'll talk about what that means. So historically, programmers have been responsible for externally iterating through Java collections. What the heck does that mean? Well, here's a real simple example. So we've got ourselves a list of names, which we get from an array. And now we're going to use the Java for each loop in order to be able to walk through every element in our list, every name in our list. And we do this sequentially. And we go ahead and do something to each element. In this case, we're going to print out the name. So that's one example of so-called external iteration. That's the for each loop variant. You can also use an iterator. This is a little bit earlier capability. Given a choice, if you didn't have Java 8, I would recommend using a for each loop. It's just a little cleaner. But it is possible, because not everything has the for each loop. In real early versions of Java, you could use an iterator. So what you do here is you have this concept called an iterator. We've talked about this before. You call a factory method in order to get the iterator to the starting point of the collection that you're going to iterate over. You keep iterating while you haven't reached the end, while there's something next. You guys have implemented the hasNext method in the array class. And then you get the next element in the collection, and you do something to it. So that's another form of external iteration. And we'll come back later and we'll talk about sort of the pros and cons of this approach. But those are just two examples of external iteration. With Java 8, you can now do internal iteration using a Java 8 stream. And here's a simple example. So in this particular case, as you can see, we go ahead and once again get ourselves a list of names. And then we're going to create a stream from this list, calling stream, calling the factory method. And then for each element in the stream, we're going to apply some action. And at first glance, this looks an awful lot like what we did before, right? So it looks a bit like a for each loop, except now we have a for each method instead of a for each loop. The difference will become more apparent when we look at more interesting examples. So this is just illustrating the concept of internal iteration, and I'll talk more about it in detail. Yes? Right. The reason is because, as you'll see, the way the iteration is done is internal to the stream. You don't have some external way of controlling it. This will become more clear in just a second when I show you a specific compare and contrast between the iterator or loop-based approach versus this approach. So what this means is it's done internally. The best way to think of it at the moment is it's done internally to the streams framework. You don't have to write any other code to direct it. So internal iteration becomes more useful as the complexity of what you're trying to do grows. So let's take a look at an example. So here's an example where we're going to have an array of URLs. We're going to convert that array of URLs into a stream. We're then going to, so now here's where internal iteration starts, right? So the flow of information flows internally, right? You don't have to write any control loop to manage this. It flows from the of statement of the of factory method through the map intermediate operation, where what we're going to do is we're going to look for all instances of csc.wustel and replace it with dre.vanderbilt. And then we're going to go ahead and take the results, and we're going to convert the string into a URL, and then we're going to collect all the results into a list. Notice how there's no control flow that we have to explicitly write. The control flow for the flow of information through the stream is all handled internally to the streams framework itself. So there's no greater control loop. And I'll show you an example of a control loop in a minute to compare and contrast it. Just a little side note, because it's worth noting, and I'll show you some really cool things about how to deal with this later. Notice how when you have operations with so-called checked exceptions, they get really ugly in the context of Java streams. A checked exception was a kind of a misfeature that was introduced early on in Java when people thought that there was a reason to want to syntactically and statically check for the occurrence of certain types of errors. Like in this case, new URL can throw an exception indicating that the URL parameter is malformed or whatever. And so the URL constructor can throw an exception. When you have those kinds of checked exception methods or constructors, it looks really nasty to write code like this. So another way to do it is to use essentially a conversion function. This is really an adapter, using the adapter pattern, so that we can essentially wrap this particular class, constructor, URL : new, with an adapter function that will convert checked exceptions into runtime exceptions. So what is nice about this is rather than having to write all this gobbledygook, we can now write code that's much more streamlined by just doing this. This is sometimes called exception laundering, and some people like it, some people don't. I typically like it. I think it makes the code a lot more readable, but sometimes people don't think it's the right thing to do. The problem is if you're going to be using streams, writing code like this is really ugly, and it detracts from the conciseness and parsimony of the streams framework. So that's just a little side tour on this. Okay, so let's talk about the advantages of internal iterators over external iterators, and this will get back to the question of how do they compare and contrast. There's a nice article here that talks about these two things, and I will summarize some of the stuff in the article. So arguably, one benefit of internal iterators versus external iterators is code readability improvement. Now, obviously, to some extent, this depends on how familiar you are with Java streams. If you don't understand Java streams, this will not look readable at all. It'll look like gobbledygook. The benefit of this type of approach is it focuses on the what, not the how. So if you really sort of understand the streams framework, you can say, oh, look, let's go through this array of URLs. Let's get rid of everything that does not contain this substring. For the things that contain this substring, let's go ahead and replace this substring with that substring. We'll convert it into a URL object and collect it into a list. So you can kind of read this thing just sort of from top to bottom without having to think a whole lot about the control flow because it's internal, right? It's implicit. Conversely, here's the same code using a traditional for each loop where we make ourselves a new empty array list, and then we externally iterate through that array using a for loop. We have if statement, if the URL contains this substring, then go ahead and make a new URL where we replace the old one with the new one, and we add it to the end of the URL list, and so on. And this is a lot more about the how, right? So we're explicitly saying how it is we're iterating through the list of URLs. We're also explicitly having control constructs, like an if statement, that check something. And to understand this code, you actually have to sort of iterate in your head to say, okay, this is going to loop multiple times. So you kind of have to read this code and look at it and sort of internally loop in your head to see that it's going to do what it's going to do. Whereas the code over here, you just kind of read from top to bottom. So you get a stream of URLs, you get rid of the ones that you don't care about, you replace certain things with other things, you turn them into URL objects, and you collect it into a list. So it's much more linear in some ways than this, which is more complicated. Another thing that you can do with the streams-based approach, because it uses internal iteration, is you can do transparent optimizations. And this is really cool. So in this approach, if we want to make this thing run in parallel, we just put the .parallel argument here. And that says, okay, I got myself a stream of strings, and I am going to do everything here in parallel now. And so this transparently makes it run faster, assuming you have enough enough URLs to care about. If you have 2 URLs, it's probably not going to run any faster. But if you have 5,000, it's definitely going to run a lot faster. Whereas this approach here always runs sequentially. And that's because it implements the accumulator anti-pattern. You can read more about the accumulator anti-pattern if you take a look at this link down here. So this is always sequential, whereas this code might be, actually this code will be parallel, but if you wanted it to be sequential, you'd go back to what we had before, which was just this. And so it's real trivial just to make this parallel, and all of a sudden your code's going to run faster, whereas this code is always going to run the same. And the effort needed to take this code and make it run in parallel is mind-boggling, because you'd have to spawn threads or use the executor framework, and what a mess. Whereas this is absolutely trivial. So transparent optimization is another benefit that comes from internal iteration, because the control flow is actually not exposed to you, the developer, whereas here in this approach it is, and you control it, literally. You control the control flow. And then arguably there may be fewer bugs with this approach. So one of the nice things about this approach, which I really like, is it doesn't split creation from the initialization of a collection. So in this particular case, you can see, you just sort of, when you're all done, you make a new list of everything that's in the stream, and that's what's used to initialize this list of URLs. Whereas in this approach, we do split creation from initialization. So you have to remember to initialize this thing, you have to remember to add every element, and it just takes extra work. So it's easy to forget to do something here, and stuff will blow up. Okay. There are, of course, some benefits of external iteration over internal iteration. So let's talk briefly about that. Probably the biggest win is that with external iteration, you get more control or finer grained control over the steps of the iteration. So you'll see here that if for some reason you wanted to change the code, so if it didn't contain this substring, it would break out of the loop or do something, right? You can control the iteration steps in a very fine-grained manner because you're writing the control construct. In contrast, with this code up here, the stream code, it's really kind of hard to stop in the middle. The only way to stop in the middle is to throw an exception, and that's kind of ugly. So it's doable, but it's kind of ugly. Another thing you can do with external iteration is you can have multiple active iterators going through a collection at the same time. So you could actually have the same, let's say URLs is the array, and we're going to have multiple iterators that are iterating through this thing at the same time. You don't always need that, but if you need that, then external iterators are a win because they keep the state in a separate object, so you can have multiple iterator objects iterating over the same collection. One could be going backwards, one could be going forwards, whatever, it doesn't matter. Whereas for the internal iteration, there's only one iterator that's taking place, and it's all controlled internally, and so you don't have the ability to influence how it's going to work. Okay, so that's just a quick overview of external iteration versus internal iteration. Does anybody have any questions about that?